All right, folks, today we're going to continue to talk about probability with our called the counting principle and permutations. It's two ideas that we're going to kind of combine in together. Our essential question today is, how can I find the total number of outcomes of a given situation? All right, so the counting principle, it's also called, in the textbook that you don't have really access to, is called the fundamental counting principle. And our definition here is, it's a process used to find the total number of possible outcomes for a situation. All right, so one small example here is, let's find the total number of outcomes for flipping a coin and rolling a die. All right, so we talked about with our last lesson that when we flip that coin, we could get heads, and then when we roll the die after that, we get 1, 2, 3, 4, 5, or 6, and then if I got tails, same type of thing. 1, 2, 3, 4, 5, and 6. So as I count that up, that shows me that I can get 12 total outcomes. But instead of creating these diagrams, I can look at it like this. There are two different things that can happen with the coin, heads or tails. There are 6 things that can happen with the die. 1, 2, 3, 4, 5, 6. If I multiply these two together, this would give me our total number of outcomes, 12. So it's a little bit of a quicker way to find that. All right, so I can use this now to find some more, some larger scale ideas. So like with your cell phones, you can create a 4-digit passcode. I'll just say on phone, if you don't have your face recognizing abilities. And let's say these numbers can repeat. All right, so for the first number that I pick, whatever it is, I have 10 different numbers to pick from. 0 all the way through 9, so that's 10 numbers. All right, because that's like the first slot for the first number I get to choose. For the second slot, same type of idea. I can repeat the numbers. So let's say I picked 8 the first time. This one I can pick an 8 as well, but I have 10 different choices. And that's no different for spots 3 and spots 4. I have 10 different choices on all of those. So if I multiply these all the way across, this tells me how many different combinations can be created. 10,000 of them. 10,000 different 4-digit passcodes can be created for your phone. Now, if you have like a 6-digit passcode, well, then that would even change. All right, so the probability then of me picking up your phone and guessing the passcode the very first time, if there's 4 numbers, would be 1 in 10,000. Not very likely, unless I know a little bit more about you, your numbers person, you use birth dates or things like that. But if you're just randomly picking numbers, 1 out of 10,000, not a very good probability. Example 3. Let's see how many total outcomes there are for a 5-unit email password. Numbers, obviously we can use. They can be repeated. And it's case sensitive for your letters. What that means is you can use capital letters and lowercase letters. All right, so we have 5 different units. So our first spot, our second spot, third, fourth, and 5th. Now, there are 26 letters in the alphabet. Well, they can be uppercase or lowercase. So 26 and 26, that's 52 different choices. Plus our 10 numbers, we have 62 options. And if I repeat it, like capital A, capital A, capital A, capital A, capital A for my password, not a very good one, but if I did, I have 62 different options on all 5. So if I multiply these all the way through using our fundamental counting principle, 916,132,832 different combinations for only a 5-unit email password. That's not including all the other characters that you can use. That's not taking the idea that you can use more than 5. Most places make you use 8. So really a lot of different things that can happen here. All right. So that's fundamental counting principle. And that adds us into, or that puts us into the idea of permutations. Permutations is an arrangement of objects in which order is important. So let's say you go to Baskin Robbins. They got 31 flavors on a 3 scoop cone with no repeats. You gotta get the flavor everywhere. All right. And for our movie quote today, speaking of 31 flavors, our movie quote is, "Life moves pretty fast. If you don't stop and look around once in a while, you could miss it." All right. So we have 3 different scoops that we're going to put on our ice cream cone. So we have scoop 1, scoop 2, and scoop 3. All right. So for that first scoop, flavor is important. So whatever it is, out of all the 31, I have 31 different options. All right. But after I've put that one on, I can't use it again. So now I'm down to only 30 options for scoop 2. And now for the last one, I only have 29. So multiplying these all the way through, and that gives me an option of 26,970 options on my ice cream cone. Another way that we see permutations, they write it like this: permutation of 10, 3. All right. This first number is kind of telling us where we're going to start at. Like on 31 flavors, we started at 31. So this first number is going to be the number we start with. The number 3 is how many numbers we're going to multiply. So this is our first number, we're going to have a second number, and then we'll have our third number. So we'll have then 9 and then 8 because order is important, and we'll go down from there. So we'll multiply those through, and when I do that, I get 720 outcomes. All right, so that's the idea of counting principle and permutations. Inside your packet, if you want some more practice, it's pages 147, 150, and 150. There's 2 150s, I know. Don't sue me. All right, if you got any questions, go ahead and let me know. Thanks.